let's go ahead and get started. A few other people are still trickling in, but I'm just going to give a little introduction here. My name is Brad Burwald. I'm a senior sales engineer with Morningstar. I'll be covering the TriStar MPPT solar controller today. And I've been with Morningstar for about 8.5 years now. And we had a lot to do with the basically the feedback on the existing product design and what was out in the market and what customers wanted to do with this product in terms of both the power electronics and the data and communication side. So we're happy to have you all witness our seminar today. So I'm going to go ahead and go through the presentation. As I said, feel free to jump in with questions on the question box there, and I'll answer those at the end. But hopefully, mostly the presentation will answer your questions, as you watch it. All right, so I'm going to get started. Also, if anyone has any major technical issues, definitely check out the GoToMeeting website. If you have any trouble hearing me for any reason, if you think something may have gone wrong, definitely ask a question that way as well. Okay, so I'm going to get started. So what we're going to be talking about today is mainly the TriStar MPPT applications, where this product is used based on its size and functions. I'm going to talk about product detail, what the ratings are, what the specs are, some of the unique features of the product. MPPT advantages. This is basically the benefits of a maximum power point tracking controller, as a type of controller over others. So it's more about the concept of maximum power point tracking. Some of you may already be quite familiar with that if you've been buying those controllers already, but I want to be sure to cover a wide variety of topics here for users of all levels. We're also going to talk about the competitive advantages of this product. So that's specifically the features that we have that we feel are a benefit or have an advantage over competing controllers that we're selling against. Also, I'm going to talk about sizing and setup, how to configure and size the array for the PPT. And lastly, product communications. There's several things here to talk about in product communications, such as the Ethernet function that's on the 60 amp controller, our data logging and MSView software. After the initial hour, I'll take just a couple minutes afterwards to give you a quick overview of the web page and the software, just a quick 2-minute demo so you get an idea. But I encourage you to check out our website to get the most information there. Okay, moving on. TriStar Applications. Mainly, if you're familiar with our TriStar PWM controller, the applications for the MPPT are very similar. And now that we have the ability to parallel the controllers together to function more as a complete system and communicate remotely, you'll find that it opens up to some larger DC applications. In this case, Scalable Telecom is our biggest, with some of our other accessories. The TriStars can be combined for systems anywhere from 1 to 15 kilowatts. Of course, residential off-grid. Grid tie with battery is also important, especially with a PowerPoint tracker. If you are selling to the grid, you want to maximize your efficiency there. Not too many PWM controllers selling to the grid because of that. RV and boating, the ability to convert a high voltage array down to a low voltage controller voltage is very important, because if you have a 12-volt battery and a high voltage array, that's key for the RV and boating market. Traffic and highway telemetry, industrial automation, and also large outdoor lighting systems as well. Those are getting bigger and bigger as LED technology gets more efficient, and definitely the advertising revenue in some cases can make a lot of sense. Here's just a shot of a couple applications. Here we've got a 5 TriStar system for a 10 kilowatt solar backup application. And this is kind of standby power for some critical loads. And this is quite common to see systems of these size. And these are really the types of systems we're seeing more of and that we're targeting with the new abilities of the TriStar PPT. Here's a weather station in Norway. We've got several TriStars in here working on both the solar as well as the wind turbines. And here, remote communication definitely is a must unless you want to hike up here. Here's a couple TriStars for an AC system. These TriStars are charging together to increase capacity, especially at 12 volts. That's quite common. So to talk about some of the product details, these are the specific features and ratings and functions of the TriStars. So as the PWM units have always come in 45 and 60. We're also offering the exact same versions of our PowerPoint tracking controller. And this is useful in that a lot of customers had asked us for a smaller size controller. They didn't quite need 60 amps in all cases. So while it's hard to scale down a PowerPoint tracker because of the cost with the high voltage, they do have the 150 volt maximum open circuit voltage for both units. But we do have a 45 and 60. So that gives you a little more flexibility and also reaches a new price point for a controller of this efficiency and level of tracking ability. The RS-232 is available on the TriStar PPT 45, so that gives you the communications and logging abilities in a basic way. And if you go to the 60 amp unit, you also get standard not only RS-232 but 485 and Ethernet. That's the most important feature and highly sought after because of basically everything seems to be getting an Ethernet port these days. And this definitely has some new features that I'll be showing you a little bit later in the presentation. And what I'm going to talk about also is our maximum PowerPoint tracking technology, which is called TrakStar. And that's more or less our brand to just identify the way we're doing PowerPoint tracking and what its advantages are. And when I talk about TrakStar, it's important to note that that is a function of both our TriStars as well as the SunSaver MPPT, which has been our little guy that's been out there in the market for about a year and a half. And while it is small, it can actually out-track controllers much larger than it. So definitely take note of the TrakStar technology across the whole product family. So to maximize energy harvest with the TrakStar technology, we're basically doing an extremely fast sweeping of the entire IV curve. I'll talk about sweeping versus dynamic tracking, but I just wanted to be clear, we're doing sweeping only and we're doing it very fast, which kind of opens up some new possibilities for correct tracking of the PowerPoint. We're able to recognize multiple PowerPoints. If you have cases of shading or mixed solar arrays, possibly giving you a bumpy IV curve. And definitely there's going to be older modules used with newer ones, different tolerances. The grid time market's quite clean and installed, but in off-grid you get a little more original, creative, and sometimes scrappy at times with your module selection. So we like to be able to do the best with whatever array is given to us. Also has excellent performance at sunrise and at low insolation levels. We want to definitely wake up quick, start charging, and try to make the best even if we got some cloudy conditions. So some topics about the thermal design. Thermal design and mechanical construction is extremely important to Morningstar as a company and as our design strategy. You'll see big heat sinks. We try to avoid moving parts at all costs. We're going out to the field, and that's usually not a very welcoming place, so we try to design them as robust as we can. First, I want to jump to the middle there. This product has a standard 5-year warranty. It is passively cooled. That means that no fans are used to allow cooling. It's all going to take place through convection, the natural rise of the heat. We have a parallel circuit design in this controller, and this takes a bit to explain, but it's an important one you'll see later in the presentation. This controller, the 45 and the 60, they're not just a giant 45 or 60 amp controller. The 45 is actually two 22 amp controllers, 22 and a half to be exact, and the 60 amp is three 20 amp controllers built inside. The reason that's important is because, like a gear system in a car, we're able to turn on and off or basically shift gears depending on the amount of power we're working with. And that has a huge impact on our efficiency. And it also allows us to spread the heating out throughout the circuit, and it operates much cooler as a result. So instead of one giant 60 amp circuit, we've got three 20s in the 60 amp. So that's important when you note our competitive differences. We also don't use any mechanical relays. Most controllers use a mechanical relay on the PV input. We have an all solid state connection, meaning we're using power MOSFETs there. The advantage there, of course, is mechanical relays fail. MOSFETs last quite long. And also, because of that, we don't have that extra power draw that coil requires. Most importantly, as you see in the next feature, we have very extensive electronic protections, including the ability to provide PV short circuit protection. Because we don't use a relay, you can't really short circuit protect a relay. They're too slow. but with a MOSFET board in there, we're able to shut it off in the event that it gets overcurrented too quickly. So that's another advantage. And lastly, we use both the combination of our epoxy encapsulation that you'll often see in the sun savers and a conformally coated circuit board, which is used on the larger controllers. Both of those basically seal the circuit boards, the electronic components, and make sure that they're not exposed to the elements, because we know these systems are often going into situations where you have salt spray near the ocean, extreme heat, other types of environmental hazards. Giant insects that like to crawl inside the controller. And I know we have our Australian friends on the seminar today, and I know you guys have got some big bugs down there. So to talk about technical specifications, peak efficiency, 99%. So basically when you have the 48 volt input, 48 volt output, the most efficient operating point, we have a peak efficiency of 99%. So only 1% of the array is lost in the conversion process to heat. That's really key. Of course, at different voltages, it's going to go down, but overall, we generally maintain a higher efficiency level than our competitors. This controller works at 12, 24, or 48 volt DC automatically. We support 36. We can even do 32 volts as well for NiCads or other types of batteries. And these are the three common batteries are automatic, and the others can be programmed using the custom set point. This is very similar to the way the TriStar operates. The maximum solar open circuit voltage is 150 volts DC. That's on both units. And from 140 to 150 volts, if the temperature gets very cold and the voltage rises on a well-designed system, and it happens to just encroach into that area over 140 volts, we will begin to do some power correction there and try to force it to not go so high and protect the controller. And that's to kind of allow for a little bit of room for error there if you get close. But you do have to size the system correctly. You do have to be careful. If you're in a cold climate, don't go too high in voltage. And most importantly, if you do happen to put, say, an extra module in series and not realize it, and you throw that breaker and hit the controller with 170 volts, it will become damaged. We're not able to protect from something like that. It's just in the more minor cases of overvoltage that we can see it coming. In this case, it hits us blind, and you can damage the controller. So be careful of that. Battery operating voltage, we can function from 8 to 68 volts DC. Maximum self-consumption, this is basically the power drawn by the controller. So this is what we're going to use, not in efficiency loss, but in self-consumption, what we're going to consume ourselves to run the onboard electronics, the power supply, the meter, and the Ethernet. And I'll talk a little more about self-consumption later. This is sometimes referred to as quiescent draw. Transient surge protection, 4,500 watts of lightning protection. Again, this isn't for direct strikes. For something like that, you need a large arrestor, but this will help to prevent a lot of the little surges you get in the ground nearby during storms. So little protection. It's still the most common failure mode for charge controllers, so we try to beef it up a bit if we can. Now, to talk about sizing, the controller is sized in watts. That's different from the amperage sizes on our PWM controllers. Because we're converting power, you don't have to worry about just amps only. We're going to take whatever voltage amperage combination is coming at the input, which, volts times amps is basically watts, and we're going to convert it to the correct output. So to give you a rough estimate of wattage here, the 45 amp can handle 600, 1200, or 2400 volts, depending on what battery voltage you're working at. And the 60 amp can do 800, 1600, or 3200 watts. Okay, this is just a rough guideline. I'll show you our string sizer later. That'll help you out a lot. But most importantly, you should know if you exceed the wattage rating of the controller, it won't damage it. It's just going to only operate at 60 amps maximum output. Okay, so if you put 3500 watts instead of 3200 on, that's fine. It's just that you may not really get the benefit of those extra 300 watts because the array is just too big for that controller. It will very often, though, just run at full output pretty much all the time. Okay. to talk about electronic protections, solar, overload, short circuit, high voltage on the solar, as I discussed. We've got battery high voltage that protect from battery overcharging in the case of some damage in the system. High temperature, again, we'll current limit. We're only going to shut down in extreme cases of very high temperatures, and the controller literally can't deal with it by current limiting. And in that case, it will still reset automatically after it cools down. Lightning and transients, all terminals, as I talked about with the TVSs. And of course, reverse current at night. You're not going to lose any power during the night to the array, only whatever the controller draws by itself with its self-consumption. Now, to talk about certifications, this controller is highly certified. We have CE compliancy for, of course, the European standard for noise and radiated emissions. We are listed by ETL to meet both UL 1741 as well as the CSA Canadian standard, CSA 22.2. We meet FCC Class B. That's a very strict standard as far as noise goes, and we've already gotten some good feedback from some of our friends in the telecom industry that say it's quite quiet. It's important to note, if you're familiar with some of the noise spikes that can sometimes, rarely, but occasionally cause interference with PWM controllers, we switch at 300 hertz for PWM. With the PowerPoint tracking controller, we're actually switching at 120 kilohertz. So that's a much higher frequency, and what it does is it spreads those pulses out into very tiny, almost like a ripple. So it's far less detectable on a high frequency controller like this. Of course, we comply with the National Electric Code. We are RoHS compliant, which means we've eliminated any type of hazardous materials, substances inside the controller's components. We use lead-free solder now on all of our products. And everything is manufactured in a ISO 9001 facility. So we have very strict quality control standards as far as testing our units with a burn-in, calibrating them digitally, logging all of the test data, and we keep all that, so we're able to actually trace back any test data from any controller that we manufacture. And that's getting to be, we're well over 1 million units in the field at this point. So let me talk about MPPT advantages. This is essentially, for customers looking for information on why it's a benefit. I know maybe customers, you've been over this yourself with people you're selling to, or the usage, but we always like to explain this the best way we can. So give some rough examples. And with all these grid tie modules out there, very high voltages, these thin film modules are quite colorful in their ratings. We just want to talk about a good way that you can look at those and gauge when it's a good fit for a max PowerPoint tracker. So, as you know, PWM controllers, they can be sized in amps. Okay, the PV array on a PWM must match the battery voltage. Okay, so, more or less 12-volt battery should have about a 12-volt nominal array, not too high in voltage, not grid tie. 24 to 24 and 48 to 48. So you've got to sort of keep them at the same level. The array is sized in amps, meaning you're going to get, it's not IMP exactly, but you're going to get an amperage rating somewhere along the curve in the 10 to 15 volt range, depending on where your battery level is. So it's usually between IMP and ISC. So you're going to add those amperages up. Of course, PWM is less expensive. It's a lot simpler design, less components. It's good bang for the buck as far as value, and it definitely has its place in a lot of applications. The TriStar is still a very popular product, but there's good applications for maximum PowerPoint tracking as well. We hope to see a lot of both in the coming time. We use a similar series switching charge control circuit that we use in all of our the patented PWM pulse charge control we use with all of our products. So when you get to an MPPT controller, you get the benefit, of course, that the array can be a higher nominal voltage than the battery. So you can actually take a 48-volt input and charge a 24-volt battery at the output. You can't do that with a PWM controller. Not only is it extremely hard on the controller, it could damage it, and you'll actually see your power output severely derated if you try to do that. The array is sized in watts. You don't have to worry about amps anymore. You can really look at the true wattage rating of the module now. And as I said before, it's a very high frequency charge control, which gives a lot of benefits. So the technology behind maximizing the power point and getting the most energy out of the module is you want to keep the module operating at its VMP, which is the voltage rating at which the module is designed. That wattage rating you get when you buy that model is based on VMP and IMP multiplied by each other. That's the wattage. Okay, so we're going to stay on that point. We want to follow that point up and down as it changes, as the module is going to adjust for changes in temperature and irradiance levels. So even if you get a cold wind or wind that changes direction and blows across the face of the array, you can see dramatic changes sometimes in the operating temperatures. So we're going to make sure to follow that. We're going to ensure that, you know, the grid tie modules, the higher cell modules, 54, 72, even thin film modules that are sort of cell-less but just operate at higher voltages, that they can be used in an off-grid application and be converted and powered down to charge a low-voltage battery. Because everyone knows that the dollars per watt on those being the prime manufacturing goal right now, that those are, you know, handily found in the market and most often at a very efficient price as well. It's important to note that in addition to DC conversion efficiency for a good design on the power electronics side, that you got to be smart too. Even the most efficient controller can give up a lot of power if it's not doing a good job at following the max power point. I'm a little surprised sometimes when I see these industry-leading grid tie inverters that when I read about tests in Photon, they sometimes take a long time to find the peak power point. You know, these are several $1,000 units, and you know, it just goes to show you got to do both, be efficient and you got to track. So here's a little bit of economics. Basically, I'm trying to illustrate here an example of the benefits of why MPPT makes economic sense, why it's worth the money. Because I'm sure everyone dreads when you're on a sales position and you're on the phone and someone says, well, you know, is it really worth it? Do you think I should fork over the money for that? You know, I'm sure this has happened 1,000 times, so we're trying to just give a simple, you know, way to estimate that. So I'm going to pull out my fake laser pointer here and show you that the TriStar 60 with the RTS added is basically a retail cost of about $258. In this case, let me minimize my display here so I can see my full page. The TriStar MPPT 60 with the RTS, which is now included in every box at no extra cost, is about $669. These are MSRP, basically suggested retail price to end users in US dollars, okay? We just give people an idea on our website. This is not any kind of required pricing. We're just using this so you can compare apples to apples. So what we're looking at is the incremental cost here is $411. You're paying that much more money for an MPPT. So if an installed PV module, you know, installed cost per watt is $4, you know, or use your own number here, you can essentially divide this $411 by $4, and if you were to use that money for solar instead of a nice fancy controller, you could buy another 103 watts of real panels, real silicon that you could, you know, hang on to, stick up on the array on the roof. So what we're trying to show here is that the boosts needed to cover the cost of MPPT, we don't know what boosts you're going to get. In this case, how much more power you'll get out of a PowerPoint tracker. That varies a lot depending on a lot of conditions, and this has been talked about in the market. But what we're going to tell you here is if you can make a reasonable guess, for this size array or larger, if you can get, in this case, 21% out of a 500 watt peak array, that's your 103 watts right there. That's your money being well spent and means PowerPoint tracking paid off for you. That's only with 500 watts. 21%, that's a fairly good boost, but it's possible. 1 kilowatt peak, you only need 10% gain to really show some benefit. So as you can see, we get much larger, 1.5 kilowatt at 7%. These are very obtainable, you know, gains from a max PowerPoint tracker. The 45 amp on a 48 volt battery can take 2,400 watts. A 60 amp charge controller can take 3,200 watts, much larger than these examples here. So you're going to get down to pretty small numbers. So my point is that I believe that that's going to make, good sense in this situation. Okay. You might have seen my slide drop out there. It's back. Okay, so moving on. That's my economics. So the bottom line for the benefits here, what we mainly try to focus on is the theoretical boost in quotes, not the power you're creating, because we're not creating any power. You're just getting more power out of the module that you should have gotten from its wattage rating over and above a PWM controller. So I'll just use the term boost lightly here. 10 to 30% gain in charging amps out of the same modules versus a PWM controller. And cold modules cause the VMP to go up. Of course, a low battery causes battery voltage to be lower. The larger the gap between VMP and battery voltage with a maximum power point tracking controller, the more benefit you're going to see out of an MPPT controller, okay? Because the further these are apart, the more extra voltage is able to be converted to amperage, and that's going to get your batteries charged. So another benefit is higher voltage wire runs. If you can wire the PV array at a high voltage, you can put the array further away from the battery, further away from the controller. You can use smaller wire. Certainly copper is expensive, so if we can save some of that, that's always a benefit. Shading, cloud irradiance, there's all sorts of things that cause strange IV curves, object shading, cloud shading, insulation levels, mixed arrays, as I talked about. So what we'll try to do is, make the best out of those situations. With PWM, you're basically connecting the array directly to the battery at the battery voltage. So it's not going to do any kind of fancy tracing of the IV curve during these strange situations that happen during the day. And then lastly, low battery protection. I'm just kind of reiterating that the nice thing about PowerPoint tracking is if you've got a system that you're trying to keep operating that's standalone, autonomous, and in the middle of nowhere, that, when the battery gets low, maybe you can prevent an LVD, because the lower the battery gets, the more MPPT is actually going to boost current. So you get it kind of when you need it the most, and that's a nice benefit. Maybe throughout the day you can cause, that many fewer LVD situations for a critical load application, such as a transmitter. I mean, if it's normal for it to maybe shut off for a few hours every night in the winter, 20 days during the winter, maybe you can get that to 10 or 5. So can't hurt, right? So here's an IV curve, a simple 12-volt module. You can see, of course, the max power point is right there. It's 17 volts, and this is a nice off-grid module, not even a high-voltage grid tie. So you're going to be working at this level instead of at your battery voltage range, okay? So as you can see now, when we compare voltage versus power is watts, this VMP, this is the highest point, and that's where it's most important. So what I want to show you here is, this is an example of basically 130 watt PV module and 186 watt PV module, one being more or less off-grid and one being more of a grid tie variety. Okay, here's the related specifications down below. You can see the VMP, which is what we're really interested in, is much higher on the 186. And I'm going to make a few assumptions here. I'm trying not to get into the hardcore solar analysis here. I just want to give you an idea of why some modules could really benefit from PowerPoint tracking. We're going to assume a 12-volt system, 3 modules each. I'm going to talk about 25°C ambient temperature, which basically never happens on a solar array, but let's just look at, baseline values. No voltage drops, perfect controller efficiency, which also never happens. Let's just get all that out of the way so we can talk specifically about PowerPoint tracking. So let me go to the next slide here. So what we're going to do is we're going to take the off-grid module first, and we're going to size it in amps for a TriStar PWM controller. Okay, so in this case, 3 modules in parallel, that's 390 watts. So we're going to take, it's about 7.8 amps is the amperage I chose that's more or less kind of in between the amperage ratings from the module specs. So 3 of those, 7.18 times 3, gives you 23.4 amps. Okay, on a PWM controller, that amperage is what's going to go into the battery because voltage is not used. It drops to match battery. So when I take this 23.4 amps, and let's assume my battery is 13 volts for all these situations. 13 times 23.4 gives you 304 watts. So that's really the power you're getting out of this when you charge with PWM. So 304 is not really 390. We've lost about 86 watts there in the process. Okay, so when we size a 130 watt module in watts, and we use it with a PowerPoint tracking controller like the TriStar, you're going to see that 390 watts is converted. Again, perfect efficiency here, but just for example's sake, you divide 390 by 13 volts, you get 30 amps. Okay, so that's your full wattage. You're going to get much closer to this level than, of course, with the 304. So basically the difference between these two is about a 28% gain. That's the most typical example of when you hear manufacturers refer to this 30% gain. It's usually that number. It doesn't happen all day long. It doesn't happen in a lot of cases, especially when the modules are hot, but it is possible. It's possible to get higher than this as well. It really depends on the conditions. Okay, so moving on to my next slide here. Okay, so now we're talking about a grid tie module. Okay, now keep in mind this module, its open circuit voltage is probably well over 30 volts. You know, you don't even want to use this on something like a SunSaver 12-volt controller because it's rated for 12 volts. The components are probably going to exceed their voltage rating, and this module could actually damage a small controller. So definitely keep that in mind first, is you don't want to blow up the controller. Okay, so that's definitely a big exclusion for PowerPoint tracking, or definitely a big need for PowerPoint tracking. So what I'm going to show here is that with this high VMP, it's far greater than a 13-volt battery. All right, so let's add up the three modules in parallel, 558 watts. So if you charge it on a PWM controller, you're going to get 3 times 7.5 amps. That's 22.5 amps. That's actually less than on the last module, which actually was significantly, let's see, 56 watts smaller. So that's interesting right away, is your PWM power is actually less. So that's 293 watts, nothing like the rating of the modules. So when we size it in watts on the PowerPoint tracker, we get the same wattage, of course. This very high voltage, all this wattage has come in partially through high voltage because it's designed for grid tie. It's probably got far more than 36 cells in it. If you divide 558 by 13 volts on the battery, you get roughly 43 amps. Again, this is an idealistic example, but it shows you that 43 is nowhere close to 22.5. There's a big difference here. You don't want to use these modules on a 12-volt battery with a PWM controller. You want to use a PowerPoint tracker. And it's scary, but sometimes I often hear of, you know, maybe an RV or caravan owner who finds a great deal. It's the lowest cost per watt and buys high voltage modules, puts them on his PWM controller on his caravan, and sure enough, he probably gets about half of this power. So almost a ripoff, really. So now I'm going to talk about the PowerPoint tracking algorithm, and this is our fancy term for our sophisticated math that our engineers put into the controller to more or less make us find the maximum PowerPoint as fast as we can, and hopefully better than the other guys. So there's two ways of doing this. Okay, the full sweep is you basically start at 0, you go to 150, and you scan the IV curve with the controller, and you see where the most efficient operating point is. It's pretty much foolproof. I'm not saying it doesn't change and it has to follow it, but at that point in time, if you sweep the array and find the VMP, that is the most efficient point. It might change on 1 second later, but that is correct. So a full sweep is definitely useful. The problem is a lot of controllers are very slow at it, and while they're looking, the IV is changing and they're not charging effectively during that sweeping time. Okay, so that's full sweep technology. So to do a better job than this full sweep, you can do dynamic tracking. And what that does is the controller will slowly trace the IV curve up, get to the power point, and then it's going to stay there. And instead of trying to do a resweep, it's just going to look up, look down, and see if the power went up. If it did, it's going to shift maybe half a volt up or down the IV curve. And it's going to basically repeat this process quickly and, inch up and down the IV curve, staying on the most efficient point. That works well as well, and you don't have those long sweeps. But the problem is it can get easily confused. If you throw some weird numbers at it, some strange IV curve shapes, it often might sit on one bump, and that's actually a less efficient power point. And to give some examples, here's an example of a full sweep. Okay, so what we're doing is we're actually scanning the IV curve all the way from 0 to maximum voltage, and then we're going to come back to the maximum power point. In dynamics, it has to creep its way up here, and once it gets to the maximum power point, it will then just check briefly up and down and see if the power got any higher. If it did, it's going to move up or down the curve and stay on that point. Okay, so that's the way dynamic working is going to work. So the problem with dynamic tracking is there's several issues that aren't ideal if you're only using dynamic tracking. And first of all, you only see what's happening right at the power point. You never really kind of step back and look at the big picture and see, what's the VMP doing? What's going on with the array? The other thing is you don't really even know what open circuit voltage is. That's important as well, because open circuit voltage is the highest voltage in the array. It could potentially be higher than the controller. You definitely want to stay under the 150 volt rating. And it's good to know what that value is, because it tells you what your operating point of your array is. And we actually data log that value daily into the controller for several months. So we store that value. A lot of dynamic trackers, they never go past VMP, so they never know what VOC actually is. Dynamic tracking can also get easily fooled by shading effects. If you have a shade on the module and you get some strange bumps, as I talked about, mixed modules, thin films have notoriously flat IV curves, making them difficult to track because the changes are so subtle that they're not always easy to see. It's kind of like, if you're standing on the floor, you don't really know if that floor is completely level just by walking across it. You're going to need like a level with, a bubble or a laser level or something like that. It's just too small for you to notice. That happens often with these modules. And the other thing is the dynamic is going to take time to reorient itself and retrack to the VMP when you have strange conditions. Unlike the grid tie market and the off-grid, our systems don't always stand still. Our systems drive around on caravans, they float on boats, they drift on navigational buoys in the ocean. They're set up on traffic trailers that are put under, trees, bridges, because they're working on the road there at that point in time. They move around. So we've got a little bit of a harder job than grid tie inverters do. So when you're doing dynamic tracking, this is basically what you're seeing. You can't see very high and you can't see very low. You kind of see only where you're at and a little bit around it. So I just kind of shaded this to give you sort of an example. So the problem is when you think you're on the maximum power point right here in the middle, what happens is when you actually reveal with a sweep the entire IV curve, you may find that you were hanging out here and the most efficient point with more power is further along the curve. But you never got there because you didn't look. And that's definitely a weakness. It doesn't happen all day during bright sunny conditions, but when it does happen, you don't want to get thrown off there. Okay, so that's the dynamic issues. So to summarize, what Morningstar is doing with its TrakStar technology is we're doing full array sweeps, but we're doing them in a unique way in that we're able to actually sweep the entire IV curve in about a quarter, at most a half a second, depending on the type of sweep. So we're able to get done and get on the VMP point quickly and get to charging efficiently and get those batteries charged up, while a lot of other products may be looking around at the IV curve. And this is important. And again, the SunSaver MPPT, it generally tracks the whole array in about a little less than a second. So very high speed in these applications. Other controllers, minimum of 30 seconds, sometimes more. They can actually get thrown off by effects from changes in the light. Even the battery voltage can actually cause some changes if the inverter has a large load or something. That can kind of throw the whole system out of whack, during which sometimes the sweep has to start all over again. That's a big pain when it takes a minute. The TriStar MPPT is going to give you the ability to sweep not only this fast, but if we see a large change in the max power point, we'll actually sweep a second or even a third time in just a few seconds to make sure that, we did in fact get it right the first time. If it's changing rapidly due to some condition, we want to make sure we didn't get thrown off and sit on the wrong one. So we'll actually sweep a couple times to be sure. But generally on a bright sunny day, we slow down. We don't need to sweep as often because things are fairly stable. Now, another benefit is we're actually using two different processing chips in the TriStar MPPT. One is a digital signal processor. This is going to be your high-speed math calculator to get the PowerPoint tracking done, provide the control loops with our circuitry, and as I told you, with our three 20-amp controllers, and make sure that, we can provide efficient PowerPoint tracking. The secondary processor is going to provide Ethernet and all the communications. So we kind of split the tasks in the controller between two different processors. That's very similar to the way, computers are using a main processor and also a video card to kind of offload some of that extra work. So competitive advantages. Let's talk about self-consumption. This is really important because the amount of power that the controller draws itself to get its own electronics powered up is extremely important. Okay, so, and also this is the consumption you're going to draw during the night. So you don't want to drain the battery all night when your job is actually to charge the battery. That's not too good. So here I've illustrated with a graph the comparison between the TriStar MPPT and two competing charge controllers. And in this case, this is the self-consumption in watts. As I said, the maximum power we'll draw at any time, even with Ethernet turned on, which other products don't even have, is 2.7 watts. Okay, so you can see during the nighttime, everything gets lower in power. We're definitely, the most efficient here, neck and neck at the 12 volt. But during the day, we definitely have some advantages over the other guys. And in the case of the Outback system here, when there's a fan used to cool the controller, it's going to turn on when you're at peak charging because it's being hot, and that's going to cause the self-consumption to go pretty high. Now, the fan's not going to run all the time. When it's not running, I imagine that the self-consumption is going to be more respectable, but in this case, it's quite high at about 9 watts. Now, to show you an efficiency curve, I'll show you our curves later, but what we actually have here is a similar curve between the TriStar and a FM60 on a 24-volt system. So what we've got here is a 33-volt peak power point and an 83-volt. And we're going to show you the output power in watts and the efficiency percentage. And we're the solid black line here. The FM60 is the gray. And the reason we want to illustrate this is because if you remember, I told you about how we're using three 20-amp PowerPoint trackers in the 60-amp. And the benefit of that is we can shift gears. When we're in the low power ranges, we only turn on one phase, one 20-amp controller. So we're like a 20-amp controller at that point. We get to a very high efficiency quickly, even at lower power levels. We're already approaching, quite an efficient peak. Here in this example, look, we're already at approaching peak with even only 200 or 300 watts. That could just be one panel. And the benefit of that is that because we come up much faster, this area between the two curves here and here is the advantage we have in efficiency there. Now you're probably wondering what this weird bump is in both of these examples. At this level, with this controller, this is where one of the other phases is activating. We've exceeded the power of a single 20-amp unit, and we've activated the second or third phase. And what this does is, normally our efficiency would start to drop off again and go down, but we actually get a bump here, and it boosts back up again. And this can happen twice on the array, in the controller. Okay, so that bump is our efficiency boost. Now, to give you a clearer example of that, this is the efficiency curve from the Outback FM60. 3 different voltages, 48-volt nominal battery bank. Here's peak efficiency, operating at, in this case, a little over 98%. It's pretty good. But, this is a 48-volt battery, and this is a 60-amp controller. You're hopefully going to want to run around 3,000 watts, 3,200 watts at most, to get your full 60 amps. When you get to that level, you're going to be moving down the voltage, down the efficiency curve. Okay, so the issue there is you're going to lose a little bit of efficiency when you go to maximum power, because it's going to drop and it tapers off from there. Okay, but this is fairly standard. About a third of the way up the power curve is where a lot of DC electronic products hit their peak. Now, in the case of the 48 volt efficiency on a 60 amp TriStar MPPT, we obviously have, again, the very quick spike, but right at the point of peak power where the outback begins to taper off, you can see here that we actually shift our second phase in and we get a boost and the efficiency goes back up again. It doesn't go much higher, but what it does is it sort of plateaus. So you don't lose that efficiency. You kind of stay high. And then again, you can see here, these ripples also take place at about 2/3 the way up the power curve. And at this point, we're at full power. We're running all three phases at 60 amps for all these voltages. Even at the 98 volt power point, we're approaching 98%. And this is for 3,000 watts. So that's really important to show this. All three of our battery voltages, 12, 24, and 48, are graphed in our operating manual. So you can see, if you just look at your wattage and trace a rough estimate of your VMP point, you'll see the efficiency. And you can look that up in the manual for a variety of applications. It's really interesting, too, when you have a very high max power point and a low battery, like a 12 volt battery, because we're actually converting very high to low buck ratio. And that's quite interesting. Of course, everyone's going to take an efficiency hit when you're going from 6 modules down to one 12 volt battery, but we hope to still be have the higher advantage there. So here's a quick show of basically the cost comparisons. All right, so when you compare the cost of the TriStar MPPT 45 and 60 to an Outback, you see a lot of different scenarios here. I just want to explain, first of all, that our controllers come standard with the RTS, so it's included in all the TriStar MPPTs. So when you add in the cost of the RTS with the Outback to compare apples to apples, you can see the cost comparison here. Also, the meter is optional on the TriStar PPT. With a lot of the new data functions, we're thinking that a lot of people might want to get data remotely or using our new web page, so that's an option. But more importantly, if you have multiple TriStars in a system, you don't need a meter for every single controller. With Morningstar's new hub, you're able to use one meter with a lot of different TriStars in the same system. So that's why we make the meter optional. Because using our dip switches, you can set up the battery that way. You don't have to use the meter. And in a lot of cases, the dip switches can be far easier to set up the battery too. It doesn't require a lot of setting up and navigating the menu system of some of these controllers at every single site. A lot of times you can flip the dip switches, put the cover back on the TriStar PPT, and ship it to your customer and tell them to just install it, and it's already pre-configured. They don't even have to power it up until they're ready to go. So in the bottom case here, we've got the TriStar MPPT with the RTS and the meter, and we're about break even with the Outback on the 60 amp unit. Now remember, our 60 amp unit gives you Ethernet at no additional cost. And in the case of the 45, we're still providing a savings of about $150 retail if you don't need the full 60 amps. So definitely give the 45 a look, because it's still an excellent controller at a lower price point if you don't need all that power. As I showed earlier, anything over 600-700 watts, it really starts to make sense for PowerPoint tracking. So let me just glance at some of the data here. Okay, just checking on questions. Again, any questions, if you're starting to pop them in there, I'll be happy to cover them here at the end of the presentation. Try and stay on schedule here. So this is the sizing calculator. This is on our website. If you click on Morningstar's products page, you'll see a link to the string calculator. We're going to add it in more places because a few people have been looking for it. So we'll try to make that a little bit easier to locate. But essentially, if you click on our main products page, you'll get the string calculator. And what this allows you to do is to punch in a module manufacturer and model, the charge controller from Morningstar, and by the way, you can manually input module specifications as well. Just make sure you get the data right. Check the decimal point. If you don't see a module on here that you think should be here, email me the data sheet, or anyone at Morningstar for that matter. We'll be happy to add it for you. When you go down to the string calculator here, after you put in min and max battery voltage and your temperatures, then what you'll do is you'll get a array configuration. And this is going to tell you the maximum array size. And on our web page, when you drag the cursor over the array, you'll get the array information down below. It's going to tell you the temperature compensated voltages that you're going to see on this array based on this data. And then you'll be able to see what you're working with. And if you get too high a voltage, you'll get blue. If you exceed the power, you'll get red, and so on. Okay? Now, charge settings. This is quite easy to set up. Battery voltage is automatic, 12, 24, 48 automatic, or you can fix it so you can lock it in so it'll never change. PV array basically requires no setting. That's the whole point of the PowerPoint tracker. As long as the voltage is higher than the battery and less than VOC of 150, you're in good shape. So the only thing you really have to set up is the battery charge settings. Okay, so you have to tell the controller what type of battery you're charging. And again, for this, we use dip switches. So when you set the dip switches, numbers 4, 5, and 6, just like the TriStar, you get a whole profile for a battery. So for gel battery, you get the charging voltage, the float, equalization has been disabled and locked out so you don't cook your gel. Absorption times, you can go into some higher, more robust battery charging. Definitely for you guys that are living off grid, they got some really big batteries that you're really good at watering them. You can really juice them up here with some high voltages, some really strong equalizations for longer periods of time. And these battery profiles are programmed into the firmware, so they're always there for you. Plus, using our software, you can also program an 8th setting. And you don't have to do this in the field. Everyone asks, well, do you have to have a laptop with you when you're doing the installation? No, not at all. If you want to pop this 8th setting in there, it can be your own, like, custom setting that you use for all of your installations. You can just program all the controllers really easily at your office or lab. It'll write it to firmware, and it's always going to be there. Even in power failures or for many years on the shelf, the number 8 setting will hold its memory. So that gives you a custom slot you can kind of work with to make your own. And if you don't want to use the custom slot later, just go back to any of the old ones. They're always going to be there for you. And in the case I said here, if gel is enabled, it really knows that it's a gel battery. Even if you were to try to equalize this, it'll actually lock it out and it'll prevent you. So in our MSU software, you can see where you can get into a lot of detail with our software to more or less show you all the different voltages, timers, transitions, things you can do with the battery. If you've got old batteries, they take longer to charge because they really suck up that current and they need a longer absorption. Or they should really go to float much sooner because, they're going to keep eating current. You can, you accommodate those settings using these custom charge settings. And that's in our MSU software. So I'm in the final section here. Let me talk about product communications. And after this, I'll be happy to take questions and show you a few other things. And the nice thing about a webinar is you guys can duck out, eat your lunch, do whatever you want anytime, and I'll be here presenting, and you can come back. And of course, if you need to get on to other things and I've exceeded my hour time slot, feel free to ditch me. So to talk about the PowerPoint tracking communications on the TriStar, first of all, I'm going to talk about networking controllers together with our new hub, controllers interacting with other equipment at the site using some of our new data ports, data logging of information at the site, and that's going to be the data logging that's going to be stored in the internal memory of the controller. We now have a lot of internal memory to record data to flash memory. And we have the ability to remotely monitor and control the TriStar from a great distance, even around the world if you want, using the Ethernet or other communications protocols. And you can also log data that way as well. So internal and external. I'll talk about that. So the TriStar hub, or it's called the meter hub, is actually designed to share a single, this is our new TriStar Meter 2. That's the new version. It's going to replace the old one. That will allow a single meter to talk to multiple TriStars using our hub. Each hub has 5 ports. This is optically isolated, so voltage cannot flow other than data, voltage and power cannot flow across this barrier. It's been optically isolated, and this will get data from all the TriStars connected to it. So it'll support up to 15 devices. That's 15 meters, TriStars, relay drivers, TriStar PPTs. Doesn't matter what mode they're in, it will get all that data. And in the largest example, if you were to be crazy enough to build a system of this size, you can see here we've got 13 TriStars, 3 hubs. We've got a meter on number 9 and number 3 here. And both these meters are going to show you two things. They're going to show you a system display that's going to give you a whole overview of all the charging data added up. We're going to show you also the individual chargers one by one if you want to drill down into each controller for their data. And it gives you a nice integrated package with just a single meter if you want, or more than one. And these can be placed anywhere on the system. Now what you'll see on the meter is when you turn the meter on, you do need to set an ID number. You put the meter on each controller and give it an ID number. Once that's done, they're all unique. It's really easy to do through the meter. It's one of the few things that is set up through the meter for this reason. And once that's done, you can hook them all together through the hub. You can search, and you'll have all your devices, your serial information, and your versioning. And then you're going to get a system display. And then that's going to add up all the chargers, add up all the loads. And then if you want to see the net current into the battery, it's going to subtract the load from the charge to see how much is remaining to go into your battery. And then, as I said, you can go into detail on each of the individual controllers as well on down the line. Okay, so that's the hub, more or less fairly straightforward. It does provide some redundancy. We don't have any kind of master-slave relationship where one takes over and the rest have to follow it, because that would require, if that TriStar got knocked out of the system or you lost communications, the others could become quite confused. In this case, each TriStar operates just fine independently with its own RTS and does not have to share that information. Since the RTS is included at no cost, it just gives you some good redundancy. But if you were to lose any one of those controllers, the rest will remain in charge just fine, and with only a little bit of loss of the array. So just some quick economics here. If you've got a 5 TriStar system, you were buying 5 meters previously. Now you can buy a single meter with our hub. Saves you about $300 retail, as well as giving you a much nicer interface, consolidated data, and basically one meter to go to for all of your system information. Now we have internal data logging on the TriStar MPPT. You can select from a variety of basically events. Now this is not like every 10 minutes, every 20 minutes, every hour. These are daily values. They're stored once per day. They're written to flash memory at the end of that day, and we have anywhere from 90 to 200 days of storage depending on which of these values you select. If you select all of them, you get 90 days. If you select only a few, you can get as many as 200 depending on how many. So if you're interested in one thing over another, shut off the ones you're not interested in, check the ones you are on our software, and you'll get more information longer that way. We got some nice features though, because we log the alarms and faults on which days those occurred and what they were. And we also, of course, min-max battery array voltage. This will make sure you don't exceed your VOC, because you'll have a nice little record of that to see how high it got every day. Of course, you're going to get your power and your amperage into your batteries. But it's nice when we have the absorption stage, equalization, and float stage timers, because these will show you the number of minutes that the controller was in each of these stages every day. And that's nice because it's going to tell you if your battery is getting a full charge, if you had an equalization, if it was successful because it went the full 2 hours, or if the sun went down and it got cut short, if your battery went into float. All that stuff is good to know, especially in hindsight when you're trying to gauge how well your battery is being treated by the solar system. When you connect the meter, you have the ability to access the log data. So when you scroll down to the bottom of every individual TriStar, and this includes the load controllers as well, will have their own load data logged, you'll get to see up to 60 days through the TriStar meter, more time using the other ways to connect, and then you can see all of the individual information. Okay, you can scroll across just the alarms and faults and just go day -1, -2, back in time in order to see the information. So, sorry, just took a brief pause there. A couple more questions coming in. If you guys can hang tight, I'll address those in just a few minutes. Now, another feature we have is we have the ability to also grab that data logging file, that maximum of 200 days of internal memory inside of the TriStar, and take that and download it using MSView. Once you grab that data, you'll get it in a little log file on the left here, and that will be stored on your PC, and then you can go back. This is a span of several weeks, and you can see those daily logged values to get an idea of how your system's doing. In this case, we were offline. This is my best graph for the daily values, so we were offline there for about 2 weeks. That explains the missing data there. So this is, again, the daily log values that's stored in the memory. But if you have a dedicated PC connection, you either have a PC or some kind of device on site that you can run our software on, or if you have a dedicated internet connection to the site and you're able to connect to it remotely, you can now set up MSView to communicate with the TriStar directly, and it's going to log this data continuously. And now you don't have to stick with daily values. What you can do now is you can actually take readings as often as you want. It could be every 3 times a day, every hour, every minute. And we had a system set up where we were taking readings every 5 seconds. We accumulated a ton of data, but we were able to see every little change in the system. And that can have a benefit as well if you want to, maybe track one solid day. You can see here where we went into a lot of detail just on one day. This is 3 days total. This middle day, you can see the battery voltage taper off. You can see the charge current drop. You can see voltage, open circuit, VMP, lots of good stuff. And again, MSView is free on our website, and it supports all of our products that are able to be used with the data connection. In this case, you also get a nice CSV data file that can be read by Excel with timestamps. So you can use some Excel wizardry to crunch the numbers and do some other analysis better than MSView can. Now, the last way you can connect to the TriStar MPPT is if you don't want to use our software, if you just put the IP address, the internet protocol address of the TriStar, you can choose that yourself, into a web browser, then you will get a web interface. It's kind of like when you set up a router, you get a little generic web page that's, kind of basic, but it shows you what you want to know. And in this case, we show you basically the live data. You can see the network settings, and you can see, in this example, the data logging information. And this is a nice example, and I'll show you a little demo of this real quick after the presentation if you stick around. And this data is, in real time. And the nice thing about a web page is it's more easily read by a lot of devices out there, including, Macs, smaller computers, older computers, even the iPhone or other smartphones that have a full HTML web browser can see this web page. The screen might be small, but it will read it. Now, one other thing is all these previous examples talked about ways that you can get data from the site and the ways you can log the data or remotely connect to the TriStar to see what's going on. But if you want to be notified proactively by the system and be told what's going to happen, when something is wrong, then there's 2 ways you can program the controller to notify you. And the way we do that is we use something called SNMP. This is a simple network management protocol, and it's a technology used by a lot of the IT industry to manage servers, routers, networking equipment. Cisco uses a ton of it, basically to view what's going on in real time from a wide array of data, maybe data from equipment that's not even in the same geographic location. Of course, the cellular telecom industry uses it for their cell phone towers. That's why we built it into the TriStar. It's a very basic implementation, but if they're familiar with SNMP, they'll be able to use the TriStar in their existing management network. That's really important for some of these big telecom companies, because maybe they're not so keen on using MSView if they have their habits. You can also use email alerts. So everybody's familiar with email. That's a good way to do it as well. As long as we have access to a mail server, usually on the internet or even on a local area network at a big building, you can send an email. And you just set up your mail server data, your username and password, and you put in the email address of where you want the information sent to. And if you get a message, you'll get a little email saying the TriStar PPT's got low battery or something else. Then in the case of SNMP, it's not an email address, it's a server address. So you just put in where the monitoring server is that's listening for the alarms, and then it'll do its job. So when you connect, for this, you can't use the web page. You have to use MSView. You can enable one of 4 notifications. You put in low battery. I'm going to look at this TriStar MPPT that I'm connected to. When battery voltage becomes less than 11.5 volts, then for at least 60 seconds, because you don't want it to be tripping all the time. Every time the battery sags for a second, you get an email. You can set a little delay here, and then you check email or SNMP or both. And then after it sends the notification, it'll tell you the TriStar serial number, what the deal is with the settings, battery's low, and then it will not send that notification again for this amount of time. So because, some of this stuff goes away on its own. If you get a low battery, maybe it just happens and then it recharges. But if you get a low battery and you get an alarm every hour for 2 days, I think you're going to have to go to the site. You get 4 of these notifications, and that's in every TriStar MPPT in the 60 amp version with the Ethernet, because we do need to be able to get to the internet. Lastly, all of Morningstar's products use a protocol called Modbus, and this is an open standard. We publish a spec for all of our products. We're happy to let people take a look at it so they can do their own thing, make a fancier piece of software or a fancier website than we can, and basically develop around it. We don't have anything cool like an app store. We're not going to sell you music, but we do publish our specs so that hopefully we can work with other companies to, do some new things. Modbus is definitely an industrial protocol. It's very stable and reliable. It's been used on all of our products going back to the TriStar 6-7 years ago, and I've recently seen it's been under discussion for a lot of use by some of the new spec. They're trying to do some standards for our industry, and Modbus is definitely at the forefront of that. So I think you'll be seeing a lot more of it in the future. This is just a quick data summary. Basically, we have a lot of different ways to get data out of the system, proactive, instant, different levels of detail. This just summarizes that. Okay. And basically, that's going to conclude my PowerPoint presentation. So we're hoping that the PowerPoint, the TriStar MPPT, is going to give you, good quality that hopefully we've been delivering all along, reliability, some new and unique features. We've got really industry-leading efficiency, and the high temperature performance is notable because of the lack of the fan. It's really a controller that's built for the rugged off-grid. It's very scalable because you can parallel it with our new hub, and it works great with the old TriStar PWMs as well, so you can mix and match them as you need. So it should give you a lot of flexibility. So that's going to sum up my PowerPoint presentation. So let me take a look at the questions here. If there's anything I didn't answer, as I said before, you can send me an email. Let me pop back to the first slide here. You can send me an email after the fact. I'm happy to, if you punch it into the question box now, I'm going to take a look at those. I can answer them myself. And let's see here. Regarding the seminar, if you would like a copy of this presentation in PowerPoint format, 2007, 2003, or if you would like a PDF file, believe it or not, the 2007 PowerPoint file is actually the smallest. It's only 3 megabytes. I can send you this presentation in any variety of ways. So just let me know, okay? So let me give a few of these questions a shot here. Someone had a question about RF noise. Again, the PWM controllers, it was minimal. We had a way to disable that and switch it to an on-off style. But as far as radio frequency noise, a PowerPoint tracker, especially this new design, should be very quiet. We've already had a few telecom companies that, to put it lightly, had some very big needs for quiet equipment, and they were quite happy with the product. Because of the high frequency, the power per pulse at 120 kilohertz is very tiny. So I think it should be fairly quiet. I can never say for sure it's going to be compatible because you just don't know. A lot of times it's the equipment itself that lacks the shielding to really operate in certain environments. So it's not even always the TriStar's issue as much as it's just some issues in the system. But we meet CE, we meet an FCC standard, which is quite strict, and hopefully that'll do the job. Let's see. Overall, the best thing I could recommend if you're interested in the part numbers and our list prices is to take a look at our website. If you go to how to buy, you'll see a way to refer to our list prices. You can see the part numbers. We have the new products are the TriStar MPPT 45, the TriStar MPPT 60, which features Ethernet, the TriStar Meter 2, the TriStar Remote Meter 2, and the hub. We have also added a product called the RSC, and what that does is since the TriStar MPPT 60 has RS45, you can plug an RSC adapter into a TriStar PWM version's RS232 port, and that product will now be also RS45 enabled. So that allows the TriStars to actually talk to each other. This is probably best discussed in another presentation, but you can actually communicate even with the old TriStars through the gateway of the TriStar PPT. So now if you guys hang in just 1 second, I'll give you a quick demo of some of the data. So let me share my web page with you. I'm seeing just a few questions. Let's see. Oh, one other question. Someone had asked for the IP rating. I would probably say the IP rating, we don't have an official rating. It's designed to go in an enclosure. It has vents in the top. It is not a waterproof product. I'm guessing that it's probably close to maybe IP 21. It's not a strict certification, so I'm just guessing. But you know, water could get in the top. It's not outdoor rated, so it would need to go inside of an enclosure or a building. So what I wanted to show you on the web page here is if you go to our website, you can click on this page to see the TriStar MPPT live demo. This is not a real TriStar because one TriStar can't serve the whole world's internet needs. We need to host it on our web server to handle the bandwidth. But if you see this, you'll get a nice little example of the live data view. And what this is showing is an example of what kind of data is happening right at this minute. Okay, so you're going to see battery voltage. You're going to see how we're trying to charge to 58.8. Current, it's in max power tracking mode. The output power, 690 watts. You get some nice temperature information, your amp hours and kilowatt hours. And here's a lot of data on what the array is doing. You get to see the current voltage, the VMP found. These are generally the same. The array current coming in. Obviously, it's lower, much higher on the output after conversion. You get to see the VOC, and this has to do with the power that was located during its sweep. Okay, so if it hasn't swept in a second, then you may see that that changes a little bit from the other one. Alarms and faults. These are going to show you if there's any errors going on with the system. So if you see none and none, that's a good thing. Now, if I click the network setup, this is a little bit dry, but for you techies, if you want to see what the IP settings are, this is just like a router. You can configure all the network data, your IP addresses, your gateway to tell it how to get to the internet, how to find, DNS is something that's commonly used. This is all your port data. This, when you have these port information, this allows you to poke holes in your firewall to let TriStar MPPT data pass through, but not everybody else. So that's a little bit of a security issue. One question that came up in the last presentation is, what about security? We don't have a password protection. This isn't a server. It's difficult to put all this stuff in a chip. And also it's hard to keep up with the changing environment on the internet because it's changing so fast. So what we did was you can disable the ability to write data over Ethernet. So if you flip the dip switch inside the TriStar, you physically flip that switch, that's the only way you can enable remote modification. It ships in the default disabled mode, okay? And that's very important because this way everybody can look, but they can't screw it up. But overall, it's important to note that if you're installing this on the internet, you need to take proper security precautions, okay? You need to use a VPN, a firewall, and not put it on the internet for everybody to play with. And then lastly, data logging. This is the example I gave you earlier. You get a nice view of the data, and I can scroll along the bottom here and actually show you up to, goes to 83 days. And you'll notice on the bottom here, the alarms, if I hover over the 3, you'll see alarms, RTS was open, we went into current limiting, and we reset the controller. I don't know if you guys can see it yet. There's like a little pop-up that appears over top of the fault down there. I'm looking at my seminar. I don't think it's showing up, but anyway, when you hover the mouse over the alarm, you'll get that little readout, okay? So that's it for the web page. And then, let's see. I believe the last thing I will show you is if you would just want to see our MSView software. This is more or less how you would use our MSView software to connect to a TriStar. Okay, and I'll do this kind of quick, but you can play with this. Just download it. It's free. You can install it. You don't even need a controller to actually play with the settings. You get all these setup options that are displayed here. Most importantly, I'm going to go to Devices. I'm going to create a manual connection. I'm going to choose the TriStar MPPT. I'm going to create that device. That's going to appear on the left. And then I'm going to go to the settings, and I'm going to say that this is a remote internet TriStar that is on the internet. And this is actually, I'm in Pennsylvania. This is actually going to connect through our VPN connection to our Maryland office, which is a couple states away. I put in the IP address and leave everything else the same. Okay, and then all I have to do is connect to the TriStar. Okay, the TriStar is red right now. When I establish the connection, it's going to turn green. Okay, it does that. There's the serial number. And now that the TriStar is connected, I can now view a lot of data. So all of those are different pieces of data parameters that the TriStar is keeping track of in real time. Okay, so if I create a little display, I'm going to create, now this is where you get a choice of you can graph, you can log continuously to a file, or we're going to do something called state, which shows you what's currently happening. Okay, so I'm going to grab the, now if you wanted, you could choose individual, you could actually grab and you could choose individual pieces of data, and you could set up like a nice little display, and you can even show other devices, like multiple TriStars. You can do more than one, and then you can show like the battery voltage for 10 different sites if you want to see that. But most importantly, I'm just going to grab the whole thing and drag it, and it's going to pull all that data, and it's going to take about 10 seconds, and it's done. So all that data you're seeing is being displayed in real time, and I can view this, I can log it, I can even see how the dip switches are set, I can see what color the LEDs are, I can see the operating mode, I can see the temperatures, pretty much everything. Okay, and that's all in real time. This is happening over the internet. If the TriStar was in the same room, I could connect using the serial port, you know, pretty much anything. And there's nothing to say you can't use a wireless connection for this. It's really a networking thing. Beyond our scope, it's more of a networking engineering setup. So, but we do have a network documentation on our website that shows you how to configure a lot of the IP addresses. We have a communications guide that'll give you some good ideas with using the the network configuration as well. Okay, so that's a little taste of MSView. There's definitely more to cover. I'm hoping to do a more detailed presentation on building a multiple TriStar system, communicating with it and all that good stuff, but that'll be for another day. All right, so that's the end of my presentation. If there's any other questions, please send me an email. And I have a few requests already here. Let's see. I would, if you had requested a presentation, if you could send me an email, I'd really appreciate it. That way I can just reply back to you and attach it easily for you. And just let me know, PDF, PowerPoint, or whatever you'd like. Okay, that concludes the presentation. Thanks very much, everyone. And I am off to bed. It's 11:20. So have a good night, or in your case, a good Friday, and have a good weekend.